Hi guys, welcome to another video where I'll be teaching math. I'm Abhinav. I've done both my bachelor's and master's in electrical engineering from IIT Kharagpur. In today's session, we'll tackle a challenging question from the test series of a renowned coaching institute known for its notoriously difficult mock tests. Yes, you guessed it right. It is from that institute. We will dive deep into the wavy curve method, a powerful technique used to classify critical points of a function into local minima, local maxima, and inflection points. This method is crucial for your JEE preparation. Now, do these questions really appear in JEE? Absolutely. These kind of questions do appear in the JEE exams. In fact, I have already solved a similar question that appeared in JEE Advanced 2021. So after going through this solution and understanding this method, I would strongly recommend you guys to solve that question which appeared on JEE Advanced 2021. The link to the video is given in the description. But before going through that video, I would strongly recommend you to solve that question or give it a try. So let's get started and unravel the secrets behind this fascinating method. Do not forget to like, share and subscribe for more such insightful sessions. So here we have three functions. So the first one is f of x, which is given by this particular expression. The second one is the derivative of g of x, g dash of x, which is given by this particular huge expression. And the third function is h of x, which is a composite function f of g of x. And the task at hand is very simple. So we just have to find out n1, which is the number of points of local minimum of h of x, and n2, which is the number of points of local maximum of h of x. Let us go ahead and try solving this question. Okay. So we are going to use wavy curve method to classify the points of local minimum and the points of local maximum here. So the first step is to find out h dash of x. And the second step is to set h dash of x to 0 and find the roots of h dash of x. And the third step is draw the wavy curve. Fourth step will be the classification. Alright, this is what we are going to do in this particular video. Okay, so let us find out what h dash of x is. H dash of x is f dash of g of x times g dash of x. We already have g dash of x here. So and we need f dash of g of x. So to do that, let us find out f dash of x. F dash of x is simply x square plus x plus 1. So put x is equal to g of x here. So that will give you f dash of g of x is g of x whole square plus g of x plus 1. So now we have f dash of g of x and g dash of x. So before going into the solution further, so let us simplify g dash of x a bit. So g dash of x is x square minus 9. It can be written as x plus 3 times x minus 3. X square minus 4x plus 3. This can be written as x minus 3 times x minus 1. And this quantity can be written as x minus 2 times x minus 1. And finally, this can be written as x minus 3 times x plus 1. Alright. So now g dash of x is simply x plus 3 times x plus 1 multiplied by x minus 1 whole square multiplied by x minus 2 multiplied by x minus 3 whole cube. Alright, this is the simplified expression for g dash of x. We already have f dash of g of x. This is g of x whole square plus g of x plus 1. So this can be written as g of x plus half whole square plus 1 minus 1 by 4. So that is g of x plus half whole square plus 1 minus 1 upon 4 is 3 by 4. Alright, so now let us consider h of x from here. So sorry, h dash of x. H dash of x is f dash of g of x times g dash of x. So we have found out h dash of x. The first step is done. Now let us go to the second step. So we have to set h dash of x to 0. So either this can be 0 or this can be 0. But if you check this particular thing, f dash of g of x, it is given by this particular expression. So this quantity is always positive. Alright, it is greater than or equals to 0. This is greater than or equals to 0 since it is a square, and this is 3 by 4. Therefore f dash of g of x is always positive. This never becomes 0. So for h dash of x to become 0, g dash of x has to become 0. Alright, so h dash of x is equal to 0 implies g dash of x is equal to 0. So we already have g dash of x, which is x plus 3 times x plus 1 times x minus 1 whole square times x minus 2 times x minus 3 whole cube is equal to 0. So now what are the roots of this? So the roots of g dash of x is equal to 0 will be the roots of h dash of x is equal to 0. So therefore these are the critical points. Critical points are minus 3, minus 1, 1, 2 and 3. These are the roots. Now we are done with the second step as well. Alright, now let us go for the third step. Draw the wavy curve. So to draw the wavy curve, you have to first draw a horizontal line and then mark your critical points on that. On the left will be your minus 3, and then you'll have your minus 1, and then 1, then 2, and then 3. So now let us draw the wavy curve. We will start from the left hand side. Let us say x is less than minus 3. When x is less than minus 3, this quantity will be negative. This will also be negative, and this is positive. This is negative, and this is also negative. So minus into minus is plus, plus into plus is plus, plus into minus is minus, minus into minus is plus. So when x is less than minus 3, this will be positive. So let us draw a curve like this. Now from here, let us say x is between minus 3 and minus 1. When x is between minus 3 and minus 1, let us again check the signs. When x is between minus 3 and minus 1, this is positive, this is negative, this is positive, this is negative, and this is also negative. So minus into minus is minus, plus into plus is plus, so this will be minus. So between minus 3 and 1, this is minus. Alright, so if you have 1 or 2 roots, checking like this is easy task. But if you have some 5 roots like this, there is a blind way of drawing the wavy curve. How can we do that? So now you hit x is equal to -1. Now you are at x is equal to -1. All right. So now check what is the degree of x plus 1. So it will be 1. The degree is 1. So when the degree is odd, you have to go to the other side of the line. All right. Now we are at x is equal to 1. So this factor gives x is equal to 1. So to check the degree of this particular factor, it is 2, which is even. When it is even, you have to stay on the same side of the line. Plus. Now we are hitting x is equal to 2. So check the degree of this particular factor. It is 1. So which is odd. 1 is odd. So we have to go to the other side of the line. So negative. Now we are hitting x is equal to 3. All right. And the degree is odd here. So we have to go to the other side. So plus. So now drawing wavy curve is also done. Step 3 is also done. So now we have to classify the points. So whenever there is a transition from plus to minus, that point is your local maximum. Whenever there is a transition from minus to plus, that point is your local minimum. Now I have a question for you. Whenever there is a transition from plus to plus or minus to minus, what do we call such points? What do we call such points? They are neither local minimums nor local maximas. But so what are those points? What do those points signify to us? I'll pin this question in the comments. Try to answer it. What do we call such points and what is the significance of those points whenever there's a transition from plus to plus or from minus to minus? And also let us see the reason why the transition from plus to minus gives you a local maximum. Let us say you have a curve like this. So this is your point of local maximum. If you draw a tangent just before this local maximum and just after this local maximum, so the slope of this tangent is positive and the slope of this tangent is negative. And this curve is for h dash of x. Alright, this wavy curve is for h dash of x. What does h dash of x signifies? The derivative is nothing but slope. So here the slope is changing from positive to negative when you have local maxima. So when the derivative changes from positive to negative, you will have local maxima. And when it changes from negative to positive, you'll have local minima. So let us count the number of local maximas. All right. So N1 is number of local minimum points. So the transition should be from minus to plus. This is one local minimum and this is one local minimum. So the answer is 2. And N2 is the number of local maximums. So the transition will be from plus to minus. So this is one local maximum and this is one local maximum. So this is also 2. So we have found out what N1 and N2 are. So what is this point x is equal to 1 called as? What do you call this point? The transition is from plus to plus. Comment it down. I have a pinned question in the comments. Answer it. And a similar question appeared in JEE Advanced 2021. You only need to know the wavy curve method to solve that question. It was basically a comprehension type question. So if you know the wavy curve method, you'll easily get 6 marks on that question. I would strongly recommend you guys trying out that question. The link to that question is in the description. Alright, and if you like the content that I'm making, hit that like button, share it with your friends, and subscribe for more such content. See you in the next video.